Hello, thank you, and thanks everyone for joining our webinar today. Today we're going to talk about how to build streaming applications with Spring XD, Kafka, and RxJava. So three technologies which are very hot, and we're very excited about this presentation. So let me just go first and introduce the other speaker, my colleague Mark Pollack. So.
Yeah, hello everyone. I'm one of the co-leads for Spring XD, and before that, I had led the Spring Data family of projects, and before that, helped contribute some messaging support into the Spring framework, as well as founded Spring XD.
Thank you, Mark. And I'm Marius Bogoevici. I'm also a software engineer with Pivotal. I'm working on the Spring XD team. And apart from Spring XD, I've been a contributor to Spring integration as well, so taking an interest in enterprise application integration. And today we're going to talk about how to build stream processing applications, as I said, with Spring XD using RxJava and Kafka. And first, to get started, I'd like to introduce the problem that we are trying to solve. And I'd like to place stream processing within the landscape of big data applications. Obviously, the domain of big data applications is very vast. So the reason why we're focusing on stream processing is because it's a very a very modern topic. And it's being prompted by a number of changes both in the technology and in the business landscape. What does it mean? It means that, on one hand, technically, there's an ability right now to cheaply store and analyze huge quantities of data. This type of processing has usually been the realm of batch processing. So normally you would gather all your data, and you would process it at the end of the day, and then you would apply the results next. But the fact that we have these, basically we have this technical ability to gather the data, we have this processing power at our hands, and also because of the increase in the number of connected devices, where they, like wearables, for example, or connected cars, or industrial sensors, has actually shifted the demands towards processing this data in real time, getting results closer to the time when the event has actually been produced. So essentially, the focus shifted towards applying big data technologies and big data application models towards real-time or near real-time data processing. Obviously, there are some of the more popular use cases are, for example, fraud detection. In there, you can see immediately a case for why would you want to have your data processed as soon as possible. So we want to detect a fraud as soon as we have a reason to believe that it has occurred. Measuring the quality of service, log analysis, for example. We want to have feedback that an application has been performing badly as soon as we have an indication that might be the case. Predictive maintenance. So we want to identify and fix failure in equipment as soon as it happens, right? Again, couple all that with the large number of devices, with a large number of events being collected from these devices, and all of a sudden we have exactly this problem that I started describing. A high volume of data, the desire to process this high volume of data with low latency, and on top of that, the requirement to process this data in a stateful and ordered fashion. What does that mean? It means that not only we want to get all this data in, But for cases, for example, like fraud detection, the sequence in which events happen is relevant to detecting fraudulent activity. So during the processing, we want to preserve that ordering. If it doesn't happen over the entire set of data, at least it should happen over a subset. For example, for a specific user or a specific application. So these are the characteristics of stream processing applications. And what we're going to try to solve today, basically we'll make use of three main components, three main technologies. We're going to use Kafka for its high volume and low latency for moving data as a transport. We're going to use RxJava for its programming model for writing our processing code. And we're going to use Spring XD and its deployment and runtime abilities for deploying and running the components that we have developed in RxJava. So this presentation will basically be about how we tie these three stories together in a very unified whole. Let's start with the first component. So Apache Kafka. We are in this talk. We're going to show you how Spring XD uses Apache Kafka as transport. Kafka has emerged in the last years as performance, high volume, low latency message transport messaging system. Its performance is basically what it makes it very interesting for stream processing is its performance, ranging in millions of messages per second. It's low latency. Structurally, it's a typical publish subscribe. So let's say from a 10,000-foot picture, it's a publish subscribe system. Multiple producer and multiple consumers consuming data shared over topics, shared over a number of brokers in a cluster. It has some, as a project, it originated at LinkedIn, and there it was devised specifically to solve the problem of processing events such as basically profile changes, job offers, and everything into a single unified stream of data, and distributing that to the various applications that make up the site. It defines itself as a publish-subscribe messaging system rethought as a distributed commit log. And we will see immediately what that commit log actually means. What is relevant is that it's a distributed, partitioned, and replicated system, which makes it very useful for distributed processing. It has strong ordering guarantees within a partition, which fulfills our requirement for processing events in a given order. And it has failover capabilities, like partitioning, for example, in distribution or replication. On one hand, on the other hand, it stores data for a limited amount of time so that it can actually be replayed in case of failure, right? And to understand what actually makes it interesting, let's take a look a little bit at its internals. So as I said, basically Kafka, interacting with Kafka is basically interacting with a messaging system that captures messages stored in topics, and topics are organized into partitions replicated between brokers. So basically each partition essentially is managed by could be managed by a separate broker, which makes it very efficient in communicating with clients. Logically, the partition model takes advantage of the performance of serial reads and writes to the file system. So essentially, each partition is a file. Writes always happen at the end of the file, so it's this commit log characteristic that we talk about. And reads occurring sequence. So essentially, each client, when it consumes a partition, has control over how it can advance into a given partition, which also gives it the replayability ability and control consuming. On the logical side, producers can actually specify a target partition for sending data. So you can either do that directly by just targeting a specific partition ID, or a logical partition key will be used for doing the partitioning. For example, we can make sure that all the data for a specific customer is written to a given partition, which is actually very important, as we will see later, in that it enables stateful processing of data, especially in a distributed environment, where, for example, if you're trying to aggregate data for a specific customer, it's very important that a processor doesn't read data from all partitions, only the one that actually has data for that specific customer. Also, in terms of ordering, the order of consumption is preserved. So basically, messages are delivered to customers in the same order as they are written. Again, a very important characteristic for stream processing. In terms of Spring support, Spring integrates with Kafka through the Spring Integration Kafka project, which is part of the larger Spring integration family. It's basically building the enterprise integration patterns and integrating them with various technologies. In the case of Kafka in particular, it provides it adapts topics and partitions through the channel adapter enterprise integration pattern. So basically, you can treat a partition as a channel from which you can receive data, like the incoming messages, for example, as events, as well as publish messages to a specific topic by actually writing to a channel. And technically, the Spring Integration Kafka built on top of the simple consumer API. It's a design choice given the limitations of the high-level consumer in 082. There are a number of issues with it. Actually, the high-level consumer is basically it's almost deprecated. It will be replaced by a newer API. Our goal, as is shown in the diagram at the bottom, was to provide the Spring-specific abstractions that isolate the user from the API underneath. So on one hand, we have the enterprise integration channel adapter. On the other hand, we have the Kafka template, which is a more basic way to integrate with Kafka using the familiar Spring template model. Pluggable strategies for offset management, message handling, or error handling are also provided. So everything is tied into a whole. This is basically what powers the Spring XD integration with Kafka. And we'll actually see a little bit later how Spring XD uses that for integrating it. But right now, I'm going to hand it over to Mark to talk a little bit about RxJava.
Hello, everyone. So I want to introduce RxJava as the programming model that we'll be using for the demos. Where this came from actually has a pretty long history going back, relatively long history going back to about 2011, where Eric Meyer created the first version of the Reactive extensions project at Microsoft. And it's sort of dubbed as being an API for asynchronous programming using observable streams. And it combines ideas from various domains, the observer or iterator pattern. They're sort of duals of each other, as well as, most importantly, functional style programming API. During the course of the history of the Reactive extensions project in Microsoft, it branched off to be supported in a variety of different programming languages. The Java version of that which we use is called RxJava, and it's primarily developed by Netflix as open source software. So the functional style programming means that you have methods that are able to operate on this iterable collection, such as map, filter, and reduce. We'll see a bunch of these in a moment. And it turns out really that as you're doing stream processing tasks, in particular trying to chain together many operations, it becomes a very natural way to do stream processing. So here's an example of a bounded stream where we just have basically a list of names, and observable is the key API point in RxJava. It's what you basically operate over, and you can create an observable from a collection, in this case a list of names, and then here we're just simply transforming it, tagging on the hello string. And at the end, you can keep chaining methods together, map, maybe do another map, maybe do a group by. And here we show basically terminating the processing by using a subscribe method. In this case, it just prints out the string. So Java 8 introduced a functional programming model as well, which is great. I think it gives a lot of people an opportunity to get familiar with that style. But there are significant differences between Java 8 Stream API and the observable. Not so much actually the API as much as the implementation. The RxJava observables are essentially driven through events. They're push-based versus pull-based. And the asynchronous nature of the dispatching in the RxJava makes it much more amenable to these type of use cases, which is an infinite sequence of messages, and is delivered in an event-driven manner as they come along. Also important characteristic, again, this couples nicely with the order of processing off of a partition in Kafka, is that despite the asynchronous execution model, you can be sure that all items are processed sequentially as they go through a series of transformations inside the RxJava API. Here is a so-called bubble diagram. Marble diagram. I always get it wrong. Marble diagram. Thanks, Marius. It's showing actually documentation from the Rx.net version. So the lambda there is the lambda you see in .net, but obviously applies just the same. So 1 goes in and 10 goes out, 2 goes in, 20 comes out, and they're all ordered. So where it gets a little more interesting is not just looking at sort of simple transformations using this API, but using these higher level functions, operators such as windowing, buffering, group buying. So in the case of what we'll be doing in the demo, we would like to do a time window over a certain period of time, like 5 seconds. But then we'd like to do a calculation per sensor ID. So we'd like to group by the sensor ID to do further calculations. Some of these calculations, for example, computing the average, those operators are available in another library called RxJava Math. So they have a variety of min, max, average type operators. And of course, if you have 2 streams that you're processing, so for example, you might have the stream that's coming in from the event source, and you might have another stream that's coming in from maybe a database or some other long-running query. You can then merge them together with the merge, zip, or join operators. So what you see down there is pretty much the code we're going to be running in a moment, and you can see it reads, I think, pretty well once you get in the flow of it, where you have the window with a certain time length. You're going to basically group by the sensor ID, then compute the average of the temperature, and once we're done computing the average of the temperature, we're going to create a new tuple class, which is just really a glorified map that contains the sensor ID and its average temperature. So that's one of the reasons it's very nice to use this API versus other techniques. So just giving a brief background on Spring XD, some of the core concepts. So one of the basic concepts in XD is a module. Module basically means, in the context of streams, you have a series of them that you chain together, and data is data is produced in a source. It's passed on to one or more optional processors, and in turn goes to a sink. So an example of this could be a real-time stream coming from Twitter, and we store this data in HDFS. So that's kind of a yellow arrow there on the right showing that basic flow. Taps are very similar to streams, except they have as a source of information basically the data flowing across one of those pipe symbols. That means you can tap in at any point in the stream and consume data. The tap lifecycle is independent of the stream lifecycle, so you could add and remove different types of analytics there without hindering the collection of data, let's say, into HDFS. We don't talk much about jobs. Jobs basically help orchestrate, for example, running various Hadoop MapReduce jobs or Hive or Pig jobs off of data that's stored in HDFS. Or alternatively, we have support for using Spark and its batch job functionality there. The stream model in XD is fairly straightforward. If people are familiar with Spring integration, it's identical. You have a variety of input sources. This is listing sort of the ones that we have out of the box. You can easily create your own as well. So you have stuff for messaging middleware. You know, a source could be from JMS, Kafka, RabbitMQ, JMS. It could be from distributed data grid, Gemfire, as well as some more traditional sources such as mail, file, SFTP. They get placed on a channel. This channel, if you're, could be in-memory channel, but more often than not, if you're doing a distributed system, there are adapters that basically take the information on the channel and send it to what we call the message bus in XD, and this is either Rabbit, Redis, or Kafka. In the processor, there are some built-in processors that mirror sort of one-to-one the enterprise integration patterns that you'll find predominant in Spring integration, so filter, transformer, splitter, aggregator. And what we'll be focusing on here really is writing custom code, custom Java code, in this case, Java code that makes use of the Rx API. And for output syncs, some of the more notable ones for this area are writing to HDFS, or Hawk, which is our SQL on Hadoop solution at Pivotal, Kafka, Rabbit, Redis, Splunk, Mongo. These are all sort of newer technologies that are relevant in the big data space. Even though right now I'm showing very simple flow, left to right, 3 steps, you can make more complex flows through the use of name channels. And if you want to look that up in the documentation later to see how that works, please have at it. So just diving a little bit deeper to make sure it sinks in Spring XD, you literally write what you see on the screen here to create a stream. It's a series of modules with a processor in between, in this case the transform module, that has a set of module options, and these are specified with -- syntax, in this case using Spring expression language expression to do a simple transformation for demo purposes. But what's very nice about this, and one of our design goals with XD, was to make simple cases of ingestion very simple. So you shouldn't have to really write any code at all to do a basic use case like ingesting data from HTTP to writing in HDFS. To focus in on the pipe symbols that you see in between on the DSL, these basically represent the transport. So wherever you see a pipe symbol, you can think of it going over the wire, unless it happens to be all in memory in a local transport. This is where serialization happens, and we use the cryo library for that. And the distributed options we offer are around Rabbit, Redis, and Kafka. So this diagram shows a creation of a stream by making a post to one of our admin servers. That's how you interact with the system, is over RESTful API. that the admin servers consume or listen to. You can run multiple admin servers. You can post to all of them. However, only one of them is elected to be the leader through a zookeeper-based mechanism. And that leader is going to act on the requests, in this case, taking the expression HTTP pipe HDFS and translating that to creating an HTTP module instance inside one of our XD containers. That's the other key element of the runtime, the XD container. You start that up literally with a command line bin XD container, and then it sends the second module, HDFS, to another container, and they communicate over the message bus or data transport using one of the supported transports mentioned earlier. If a container fails and its modules go away with it, of course, then we have the ability to reassign them to other containers if they're available, or wait until such time as new containers were deployed so that the stream can be at its normal sort of design capacity. All container state is stored in Zookeeper as well, and that's how we keep track through the use of ephemeral nodes if containers come and go, and which processors they had on it. So to take it one step further, to kind of start to connect the dots between XD and Kafka and Rx, I'll hand it over to Marius, who will talk about the interaction of XD and Kafka in one more level of detail.
Sure. Thank you, Mark. So, yeah, as Mark has just mentioned earlier, you can configure different attributes of your stream. You have to configure different deployment strategies for a stream. And one of the very important features, one of the very important characteristics of a stream is partitioning. So that becomes generally speaking, what we want is, like in actually in a lot of cases, especially the ones that use stateful processing, like for example calculation of averages, it is important that data, as I said, from a given customer, for example, is always processed by the same component. Why? Obviously, data affinity makes it more performant. Secondly, it reduces traffic because there is a very clear distribution of concerns between the various instances. And so, to that end, Spring XD supports partitioning through as a property of its deployment manifest. So, if you're having, for example, as you see in the picture right here, a processor, and you want to deploy multiple instances of that processor, we're going to see that how to do that in a demo. I can also specify how, for example, the data should be partitioned. So we can define, like you have a very rich set of options there. You can define an expression, which is nothing but a spell expression computed on the message in transit. But you can also define, for example, you can even register your own class that if you have a more complex computation taking place, the end result is that Spring XD will send data from according to the partitioning strategy to one or the other of the components. This actually ties very nicely in the way Kafka handles partitioning, because when using Kafka as a bus, the partition key expression maps very well to the Kafka producer partition key. So essentially, we can target and make sure that, for example, as you had for this partition key expression that uses the sensor ID for partitioning, we can make sure that sensors with like the data from the same sensors is always written to the same partition. Obviously, this is supported for other types of buses as well, like for Rabbit, for instance. But in the case of Kafka, the important part is that this support actually uses the native partitioning abilities of the middleware. Moreover, that translates in the way, for example, data is consumed, because each processor instance in Spring XD will consume data from one and only one partition only. So that also using Spring Integration Kafka's ability to focus on specific partitions when consuming, it's actually making the listening to Kafka and receiving data from Kafka very, very efficient in this scenario. So that's the integration with the middleware. At the other end, the integration with the programming model. Spring XD comes with its own, with its support for RxJava in the form of its own RxJava processor that actually is a wrapper around the RxJava API. It allows you to register, like to implement it allows you to basically implement a simple processor interface that converts data between tuples. For example, a tuple, like a sequence of tuples comes in, a sequence of tuples comes out. Noticeably, the processor doesn't actually, process the tuples. It describes the transformations that the tuples should undergo. So you have this functional programming model that Mark has already mentioned that says, well, the stream, the input stream was basically should be mapped by windowing, for example, over a given time frame, and then calculating the data for calculating the average, for example, for the data in that particular time frame. Spring XD's job is basically supporting this processor model, but also connecting it to the bus. So what happens is that the data from a Kafka partition is converted to the bus integration in Spring XD transparently, converted to an observable that is passed to the processor, and then the data emitted by the processor to the output observable, again, is transparently sent to another, again, sent to Kafka, right? So again, this is the other end where the integration takes place. And to actually illustrate how all this effectively happens, we have a demo that will take one typical processing example, and we will show you how to actually build it and deploy it with Spring XD. So what our example does is basically given given a number of sensors that transmit their temperature data, we use an HTTP endpoint to receive this data, and basically a script to generate it. So given this incoming JSON data, which you see is basically a pair of sensor IDs and temperature value, we want to calculate an average temperature for each sensor, with a certain frequency over a past time window. In this example, it's going to be calculated every second over the last 5 seconds, and then we want to find what were the top N, in this case top 3 sensors with the highest average temperature over the last 2 seconds. We're going to implement that as a distributed pipeline in which the job is divided between computing the average values and tallying the average values together. So we have this average temperature and top sensors components that actually do the work. Moreover, to make it all the more scalable, so to speak, we will distribute the computing of averages across a number of component instances. Since obviously we don't want to, for example, since we want the data for a given sensor to be processed by the same component, it wouldn't really make sense for it to be fanned out to both components, which will essentially calculate a partial average. We actually want to get the entire average for all the data that has arrived within 1 second. We will make sure that data for example, for all odd sensors are sent to one component, and data for all the even sensors is sent to another one, right? So we will use partitioning, the Spring XD partitioning, to that end. So how we do this? First, let us take a look at the components themselves and how do we develop them. So let me just show you the first one, which is the component that calculates averages. So here it is. You've seen an example of the code already. It's a bit more elaborate in the sense that not only calculates the averages over a specific time window, but it's actually a shifting time window. So basically, what we do is, like soon as I said, like calculate data every second over the past 5 seconds. The transformations basically of the data are that data is grouped by the sensor ID. Is like for each the stream, basically what that results in creating a number of separate streams that are processed by calculating the average for each of it, and the result is essentially a tuple that has that contains the ID of a sensor and the average temperature over the given time window. And everything is tied together and flattened into an output stream, right, that is sent back. So as you see, all of this is basically not involving Spring XD at all. And actually, what makes it very, very powerful in that sense is that it's very testable. So I can write unit tests, and here we rely, for example, on RxJava's support for testing, in that that allows us to not only to test by emitting data to the input observable, but also to actually simulate the passing of time. So even if like normally if we were to test manually, we would have to wait a second and make sure that the observable that the processor emits data every second, or emits only data from a second. In this particular test, I don't have to do that. I can simulate sending emitting tuples at given time intervals. So, for example, you have an example here of how can I simulate the sending of a tuple after 500 milliseconds. I can test that, for example, if from the test's point of view the time hasn't passed, there is no output message, but once the time advances by a second, then the time window is complete, the data is computed, and then I can test that the results, for example, match the expected averages, right? So running this test is actually very, very quick, and as you see, it doesn't even take a second to run. Once I have my once the module is developed, obviously I can package it as a module. A Spring XD module is nothing but an application context definition. So I have here. I just have the wiring of the input-output channel and a utility wrapper for interfacing between XD and Rx. Options can be provided for the module in the form of metadata. They will actually become available for us after we deploy the module. And again, I can test all this without even deploying everything in Spring XD by using Spring XD support for integration testing. So we have the single node integration test support that starts a full-fledged Spring XD server, allows us to to deploy the module inside this test instance, and even actually test it with a stream definition. So let's run the test very quickly. And as you see, the server starts. Hopefully we will see that everything is green, and we can move on to deploy and the deployment module and start a stream. So while we're in here, while we're testing, obviously the tests run because we start an instance. Take a look at this. This, for example, is the tuple class. As Mark has said, is just a simplified way of describing an ordered key value pair inside Spring XD. So if you have some, like, if you don't want to use your own POJOs, or you don't want to create specific classes for storing data, you can actually use it to pass data between modules. Now, once everything has been certified, everything we know that it worked, it passed all the unit tests, we can actually go and build it. So while we're building the module, I'm gonna actually start Spring XD. I'm gonna start an administration node, and I'm gonna start 2 container nodes for the demo. So the test is running. Let's wait a couple of seconds till the test starts. The build is successful. We have started the administration server. We have running containers, so we can actually move forth and deploy the module. I already have started a Spring XD shell here. Let me just show you how that works. Here it is. So now I can go forth and deploy the first module. For that, the Spring XD shell is basically one of the ways of interacting with the Spring XD cluster. Is the way we can actually administrate. You can create, deploy modules. You can create and deploy and manage streams. The other way of handling that is to the administration UI, which I'm going to show you in a minute. So here through the shell, we're actually uploading the jar. We're specifying that it's a processor and its name is average temperature. So if I go here and say, well, show me information about the average temperature processor. Here it is. Even tab actually works for completion. This tells me some information about this processor that I've just created. It locates it. It also has some information about the parameters that the average temperature sets. So I can actually I can even customize the length of the time window that I do that I calculate averages over, or the shift. So now that I have the module deployed, I can actually go and create a simple stream. So I have created the stream is deployed. Let me show you the other another view. Here is the administration UI, where actually I can see the stream deployed, running, and you can even, like this is an upcoming feature of Spring XD that allows us to visualize and even create and even have a pretty nice UI for creating stream definition. So let's start generating the data. Just to give you a hint of what the generated data looks like, it's basically just a sequence of JSONs like this, sensor ID and temperature. So we're going to start sending data to the processors. As you see, first you can see the data flowing through. You already see the message rates being updated. not a spectacular rate right now, but we're actually not sending a lot of data. This is just like for keeping the rates low so that we can actually follow a little bit around here. So let me copy some of the output data from the average sensor. So here it is. That's basically there are average values calculated for each sensor ID. So now that we have this in place, let's build and deploy the other module. Okay. I'm going to wait for it to build all the tests. Meanwhile, it's ready. So essentially, with this module, we're going to do exactly the same thing as with the other one. We're going to upload the jar. We're going to specify the type and give it a name. So the build is complete. We can actually upload it. We've uploaded it, so we can create a stream. Because we want to actually set some parameters on this stream, we're going to use a slightly different stream definition. So first, obviously, we need to add the additional module in the stream, so the top sensors. We're going to add the configuration parameters for saying how many values we want to actually tally. And so far, this just creates the stream. For deploying it, we're going to specify properties such as the module count and the partitioning strategy. In this particular case, so the properties that I'm passing along here are a count of 2 for average temperature. So to remind you, we wanted to have 2 separate modules. So two average temperature counters, and we wanted to distribute the sensor IDs between them. So we're going to use the partition key expression, which is nothing but the sensor ID. Internally, the default strategy for Spring XD is to hash this value. So eventually what will happen is that, and do modulo by the number of modules. So indeed, the odd and even numbers, the odd and even sensor IDs will be distributed to the 2 running modules. So I'm deploying the stream right now. Let's take a look. Let's take a look at how that looks like. So as you see in the administration UI, the stream has been deployed. We have 2 module instances, average temperature 1 and average temperature 2. They're running. They're computing averages here. So you can see the average being emitted every 2 seconds, right? And actually, we've done a trick for this demo, which was to skew the distribution of data so that it favors modules with higher IDs. That's just because we want to to demonstrate this by giving some sort of a deterministic output. One way of showing partitioning right now is by killing one of the modules. So what I'm going to do is I am going to stop one of the containers, and basically one of the modules will stop processing data. So as you see right now, there are no even numbers contributing to the top n numbers. This is because the module that has been processing the even numbers is currently stopped. Restarting the container and restoring the normal state of the build is actually once once they start, we'll actually see the normal data being resumed. Obviously, this all could have been avoided. For example, if I had a hot container waiting nearby and running, and basically, in that case, the failover would have been completely transparent. So here's, for example, the data distribution being restored right now, and after deploying an additional container, you can actually see that even if this container has stopped, the other one takes over, and basically the failover is transparent. I can't even move that fast so that you can actually see the module being moved from one container to the other in the administration UI. So that's pretty much it, our demo for today. And I'm going to pass back to Mark for to explain the future directions and conclusions.
Okay, thank you, Marius. Yeah, just a few more slides, then we can have a bit more Q&A time. Some directions that we're going is to have a more fluent API for creating streams. So this is a type-safe equivalent, so to speak, for the DSL that you were seeing with pipes and filters. But what makes this interesting is that you can have as a processor a Lambda expression representing a Java 8 util function, or use a Rx observable API. So the process Rx method here basically accepts an observable function that transforms from one stream into another. You can try this out actually at the GitHub location listed there. We didn't show much of the UI in terms of its designer capability, but that is a future direction in terms of being able to monitor as well as design streams in an HTML5 style browser application. And that brings us pretty much near to the end. What I want to emphasize is that Spring XD integrates with a wide variety of technologies. We chose to focus here on RxJava and Kafka, but Spring XD is very flexible. For example, you can use other messaging middleware technologies for the message bus, such as Rabbit. Nothing prevents you from writing normal imperative code in Java as compared to this functional style, but we've made the integration with RxJava, as well as we've made integration with Spark streaming. So if you wanted to use all of our input and output adapters instead of writing receivers in Kafka instead of writing receivers in Spark, we provide that bridge into Spark streaming. So you can still use our deployment model, and only the parts that use Spark for the stream processing will run on the Spark cluster. You can still use the same DSL syntax, and we bind to the message bus inside the Spark runtime in order to get the data. The pointers, basically, for more information. Spring XD project homepage is the first link. You can find a video from a previous meetup that was delivered, as well as an interesting case study. RxJava, those are the relevant links. Same for Kafka. And this webinar is going to be posted in about 2 weeks to both the blog and to the spring.io/video location. So with that, I'd like to thank everyone for attending the webinar, and we'll be here to hang around and answer some questions that you have. I already answered a few in the chat window. So feel free to fire away.